Hey David, can you hear me?
I can, Sahaj. Yep.
Right, we will start in 5 minutes. I'll just wait for more people to join in and also adjust my desk cam till then. Yeah, I'm not saying anything, Robert, right now. I was just setting stuff up. All right, um, here we are, episode 174. In today's episode, I will be showing off the Thor 96, the board that you guys saw while I was setting up the desk cam. And yeah, we'll go through the entire hardware, whatever is on that board, because that is much more than your standard 96 board specification. It has lot of surprises under the hood. It's based on the IMX 8M from NXP. So it's sort of an industrial grade stuff, and which exact industry will go through that as well. This board will launch on our website by the end of this week, which means tomorrow, because I just got all the documentations and images and all of that stuff for it. Mani, who you'd have seen in the call before, already did a lot of upstream. So apart from HDMI, I think pretty much everything on the board works with upstream Linux. Um, yeah, so actually, before we do that, last week we did the whole Xilinx stuff. I still have to write the blog for it. We created the Vitus platform for running Linux applications. Um, and this week, actually, before I start, I'll like to share a few blog posts that were created by Servando and myself over the last week. So, just a second. And all right, A13 Tech is joining us from YouTube. He isn't able to join us on the call today, so that's fine. Just make sure you are asking questions, and that's about it. And David Tischler is here, so I'll promote him to panelist as well. Right, so we've had two blogs, one from me after a long time, and another one from Servando. So he's working on his AutoWare Anywhere project or AutoWare Everywhere project, where he just enables AutoWare on a bunch of 96 boards. Um, I haven't asked him yet, but I plan to have him on next week if that's possible. Sometimes the timing don't always agree. The next blog I'm sharing is my own blog, which is the introduction to the drone project. And this is the drone that you all may have seen in one of the previous episodes. Um, I blew up. It's the main controller mezzanine I was using. So that has now arrived. So I'll be doing many more updates on that as well. I did not post the link to that. There it is. So these two blogs, go check them out on the 96 Boards website. And I've posted that on YouTube as well. So, right, moving on to the Arrow and e-info chips, Thor96. So, just a second. So, this is the Arrow's webpage. As I said, it's already on sale at Arrow for 368 USD. Again, it's an industrial grade board, so don't expect the price to be low. And it's actually not that low, not that high considering what all it can do. Um, so just a quick look. IMX 8, 2 gigabyte of LPDDR4 with Cortex M4 at 266 megahertz, couple of HDMI ports, and a bunch of other stuff. We'll go in detail right now. So stop the screen share, and now I will move on to. All right, so A13 Tech says, if you don't have time on this opener, can you update me on about the drone in on Discord? I will be happy to do it on Discord, but in case we do end up before time today, then of course I can give you an update on the drone as well. So, all right, going back to the AIML board, or sorry, the Thor96 board. Forget what I just said. I am switching over to the overhead cam, and the mic, and people can still hear me, I think. All right, so this is a unique board, as you can see. Uh, this is not only is it CE extended, you actually get this board in this form factor with the base and the fan. I do have the developer version of this board, so which is I think the second to last revision that they made. And Yeah, so there are some discrepancies in the design, but I'll go through that as well. So what at the end, what you get is a very close version of this unit. Um, so first of all, what do you see on the actual board itself right now is the regular 96 boards part, which is just this much, and then this is all extended bits. And it's easy to get confused because this thing actually has dual HDMI ports. Both run independent, they don't copy each other. Again, you can set it to be mirroring. It's not that big of a deal. But the main one is directly from the IMX8 sock that lives underneath it. So you can see the grids maybe, and I'll open this up, don't worry, I'll flip it over and we'll see how the bottom part looks like. I'll remove the heatsink and show you the actual sock as well. Um, so that's your HDMI that is directly from the sock, and then this one goes through the DSI to HDMI converter chip, and that's how you get the second HDMI port. Next up, we have two USB 3 ports. So again, directly from the sock, no magic there. A single micro A port for your debugging, your regular 96 boards header, and let's then a gigabit Ethernet directly from the sock. Um, Two audio jacks. I'll come to that. There's some difference here with the final revision. And yeah, so let's move on to what all there is special about it that's not on your regular um, 96 board CE board. We have a CAN bus here. A few of our other boards have, but again, it's not a requirement of the 96 board CE spec at all. But we have a CAN bus, that is what they use. Right next to the CAN bus, we have the UR debug port. It's actually very, very tiny. They do provide a special cable for it. So, like those three tiny pins right there. Um, your second USB port, your Ethernet jack. This one right there is the JTAG debugger for the SoC. Comes in very handy at times. Your boot select switch, if I am correct. Mm, Yep, boot mode select switch. So there is no onboard storage, but there's SD card, and I think there is SPI flash as well. I think I'm pretty sure there is a spare flash, and we will find that. Yeah, it's mentioned in the hardware uh, block diagram, which we'll go through again. So I think this is the spare flash, because that chip is the closest to what looks like one. Um, and this little thing, you'd be forgiven to believe that that's a Wi-Fi chip. It's not. It's an onboard Zigbee chip, and you have your Zigbee interface here. Um, and so Zigbee, CAN bus. The second audio port on this board is actually not on the final production board. But this gets converted to something called the A-B connector, A to B connector, which is uh, automotive standard for audio connectors, so that you can have it connected to your internal audio system on your car. And yeah, so dual HDMI ports, Zigbee, automotive connections, CAN bus. This is sort of aimed at the automotive crowd and to be used in that scenario. And that is your Wi-Fi chip. So you can see the antenna traces here and a big blank space, and the antenna is just coming around here and moving here. So that is your Wi-Fi chip right there. And apart from that, yeah, a lot of power management stuff here, power and reset buttons from the looks of it. And that's about it from the top view. Let's open it up and see what there is. So again, you will get it with the base and the stand and the fan all included. The fan plugs in here, so you can remove it if you want to. And yeah, I am expecting again some bodge wires down there. So again, because this was a pre-production model, again, yours won't be your like the final production board doesn't have any bodge wires. Of course, they revise the PCB. And yeah, so while I'm opening this up, if anyone else has questions about this board, feel free to ask. Let me check the YouTube chat as well. Nothing there.
Sahaj, if I missed this already, I apologize. But what are some of the main use cases of a board like this?
So this has, I think I didn't get to that point yet, but this has like
if you want to do it later, that's fine.
No, that's fine. That's a good question at this point. This has to this can do dual 4K video decoding and encoding. So it's really towards the automotive spec. Again, everyone just puts IoT in their brochure and stuff like that, and we are supposed to say IoT, but truly with the CAN bus, with the dedicated audio port for automotive, and the Zigbee, because a lot of automotive cars and stuff they use Zigbee to communicate to nearby sensors. Um, it really is something that's designed for that particular purpose, is to be put inside a car. And let me just like see what they have to say.
Got it.
um Robotics, drones, um building automations, wireless monitoring, kind of the general stuff. But from my experience, um, drones can be another good example. But I really think this thing can be put inside of an automotive vehicle, whether it's autonomous or not. That's another story. Right, so here is the bottom side of the board. Uh, Not a whole lot, a lot of just passive components. I think some of them are just PCI switches for the Ethernet port, and some power management stuff I can sort of guess here. Um, yeah, and then there's a sock. So we'll remove the heatsink, and in case we have to replace the tape, I actually have a roll with me here, so we can replace that. Um, and then we have the 2 gigabytes of LPDDR4 memory as well. I'm not sure how they are doing this in the final production version, but some of the renderings actually have a canned space here, but it seems that uh, they're not using that. So they have, I think, if you can see, they have these little shims here to put the can on, but again the can's not really there. So let's see if oh, that was pretty easy to take off. And honestly was not expecting it to be almost bare die. I was really expecting it to be a metal can, like on the sock, like you have with the Arcade 399 and the newer Pies. I was really expecting something like that, but this is actually pretty good if you are running in an industrial space where you would want to have copper heat pipes to reduce the height footprint. So you can just have copper heat pipes running like that, like in a laptop, and that would be it. The RAM is actually by Micron, and it's rated for pretty high industrial temperatures. So I think that's pretty good. I will zoom in and see if I can show you guys the sock itself and what's all written on it. People are usually interested in that kind of stuff. So let's see if I can zoom in that much. If not, then I will probably, I can zoom in that much. Oh wow, that's a very nice zoom there. There it is. Let me clean that up and maybe fix the focus a bit more. Yeah, the focus isn't great at that much zoom. Let's see if I have anything to clean this with. Otherwise, I'll just have to like move the camera, which during a live stream isn't that pretty. That's some isopropyl alcohol for you. Um, yeah, there is your sock. Actually, I'll zoom out and hold the board so that you can see what all is written on there. Even I'm interested now. Think that's about right. have a bit of patience till I figure out how much I need to zoom focus this thing at. And there you go. I think it's pretty clear at this point. So it basically has the IMX logo or the original Freescale logo. Um, and it says WIWX8 and a bunch of other numbers on there. And it's made in Korea. So it has a Korea tag on there as well. Um, so yeah, pretty neat. I wasn't, yeah, that's a nice surprise to have that sort of a sock where everything else is visible and it's die only, easier to heat, cool down. Um, does it have a power header excluding the low speed header as well, or just a barrel jack? That is actually a good question because there are pins in this and the final production model that are right there. Um, so actually, let me just put back the heatsink. I think the compound looks all right, so I can just put it back without caring, and it's back pretty well. Uh, A13, I will check it live right now if that header is directly connected um, to the power barrel jack because it definitely looks like it is. And put the fan back on. And time to screw it back again. So more time for questions if anyone else wants to ask. Actually, I'm just going to put the two screws because for the purpose of this video, I don't want to have too much dead air. Right, time to bring up the meter and see if it's actually the same thing. So let's see where we can test this. No, it's not. It doesn't seem to be. So no, it is only with the barrel jack that you can power it up. I hope that answered your question, A13. That is definitely some other test point and not power. That was good to know. Um, right, so let's go to the more detailed block diagram where I can also tell you guys what actual uh, chips it uses from which company, and they have a bunch more details on that as well. So here I am, move that to the main camera. And my mic. All right, moving on. Let me screen share again. Um, and during screen share, the problem is I won't be able to read the chat. So I can read the YouTube chat. I won't be able to read the Zoom chat. Zoom now apparently hides the chat when you are screen share. And that was a thunderstorm. So you will have to speak up or wait for the screen share to end. And where is it? There we go. Right. So this was the document I was going through. Um, I think we covered all of it. Uh, and then board overview. And this is something that I really wanted to go through in detail with you guys. So we started the 12-volt jack, and then we have our 12 to 3.3 3.44 converter from Linear Technologies, and then we have a 5-volt converter and another one from Linear Technologies, um, which goes to your all the peripherals that will require a 5-volt input, and then another 3.4 to further step down to multiple voltages required by the SoC and memory and stuff like that. We have the actually just the memory and other sensors and chips. We have analog devices one, and then we have the IMX8M PMIC chip that runs the SoC and other stuff, which can also be directly controlled by the PMIC driver if that's upstream through the I2C header or the I2C pin. Um, and again, we are going through what all is broken out of the main SoC and how they do it. So for Wi-Fi, we use SDIO, which is it's an interface. I think even the V3S uses the same thing if you're familiar with that chip. And we have the Wi-Fi module, which I just show you. It's actually not a module. The chip is actually soldered onto the board. Um, and so it does AV, GN, and I think AC as well, plus Bluetooth 4.2. So dual band Wi-Fi and then Bluetooth 4.2. Um, Going down, USB OTG1 directly from the sock directly goes into the USB connector. USB OTG2 has is a USB 3 OTG, which goes into a Cypress hub that goes on to the dual USB 3 ports. Wow, that is actually interesting. So they are doing the Wi-Fi over USB using a USB to UART converter, and then from the UART to Wi-Fi. This is, I think, the first time I've seen it being done this way. It's usually directly over UART or directly over USB, but it's interesting they're doing it this way. Um, and So that goes as USB 2 into your high-speed connector for the USB 2 interface up there. So you have multiple MIPI and CSI I2Cs. One of the I2C goes into the EEPROM, which I thought was an SPI EEPROM, but it apparently is the I2C variant, which is fine. And then the rest go into the high-speed connector. Again, MIPI DSI, one, like I think one channel goes to the HDMI and onto the second HDMI connector, which is near the which was near the Ethernet port, and the other goes through a switch to the high-speed connector, um, and from there you can attach your own display. A native HDMI port, which is the main HDMI port on the non-CE side near the USB ports. Another SPI flash, so that's why I was confused. So there's an EEPROM, I2C EEPROM, not sure what it's doing there. And then there's a 32 megabyte NOR flash, which is a good size, and you can put U-boot and other stuff on it. I'm not sure if it's actually being used. Uh, I'll have to figure that one out. But it's there and it's there for anyone else to use. And then SDIO goes onto the micro SD card. that we saw, and you can boot off it directly as well. Um, Audio codec for one of the I2S pins um, goes to the audio jack plus headphone jack, and the other one goes to the A to B connector uh, through the automotive audio bus converter codec thingy. And then you have your different clocks, oscillators and stuff. Has an RTC built into the sock, so it could be that one of the pins here are actually for the RTC. Um, yeah, could be. And then on this side, of course, you have your RAM, your on-off switches, low speed connector stuff, which is your bunch of UART, I2S, SPI, GPIO, your regular thing. GPIOs also break onto the onboard LEDs, part of the spec, and the Zigbee module, which is not part of the spec but is as an external module connected. Um, and then through the SPI and GPIOs, you get your CAN bus, controller, transceiver, and finally connects to the connector. Uh, RGMII 5 for your Ethernet port. So you get your gigabit Ethernet, three regular switches, DPIC port on your main board, which I uh, showed you earlier for with JTAG near the low speed header, and from there we move on to the UART port, which is the 3-pin debug port. Again, it does not use the UART on the low speed header. Um, so it does say, I'm not sure if it's mentioned here, um, but it's actually a micron memory for the RAM, which is again, as I said, industrial temperature tolerant. Um, and as it said, it has a NOR flash as an option in absence of a micro SD card, so you can possibly boot off of it if you can um, condense your system image into RAM and CPIO, which is basically RAM disk, into like a single image that is less than 32 megabytes. It's not impossible. I have tried it. You do get some very basic stuff working only. But in that case, if you can condense it that much, um, then you can just boot Linux off of that chip, or you can just use it for U-boot, which is always useful. The 12 volt input on the low speed header, I can't remember about that in the specification. Yeah, the low speed header actually has, not sure if it shows here, but one of the edge pins right there actually use is a sys DC in out. So if you provide DC voltage from here, it's directly connected to this pin. Or if you provide, you can also provide your sys DC voltage from here, and uh, it will be the same as providing DC voltage from the barrel jack. That's in the spec. Um, yeah, again, they don't say why the EEPROM is there. It's just there. Maybe sometimes you want to save some crypto keys or some weird stuff like that, and you just use your EEPROM. Um, yeah, so the video part was interesting, as I said before. 4K Ultra HD at 60 hertz. I actually have a 4K TV right now, and I can check that, which would be interesting. Um, and then DSI to HDMI, as I said. Audio, I went through that as well. So BGN AC, dual band Wi-Fi. This is the particular module if anyone's interested. Um, yeah, I think we basically covered everything else. So yeah, here it is more interesting. For so the 40 pin low speed header. Here's the pin, sys DC in, and we actually have two of them, uh, just to compensate for the current draw that might occur on these pins. And you can connect two of these and two of the ground to a fairly thick wire, and you should be able to power your board without any issues. Um, yeah, that's about it. That's the overall hardware of the Thor96. A bunch of things you can do, mostly automotive grade. So let's try and boot this one up and see if that actually works. I don't know what SD card I have. It's completely possible that it doesn't boot and doesn't give any output. Um, but it's worth trying. I think I was messing around with the image it has, so I'm not entirely sure. So let me just grab a longer USB 3 cable, and then we can try that out. So again, I'm using my capture card, the same one I used during the um, which board I was demoing. We just had so many boards in the past. Uh, Keep forgetting the name. And let's just add this one to the main HDMI board. That's not the main one. And I will switch to the capture card. So if everything seems blank, that is sort of what it's supposed to do. And let's see if I can just pull this out. And hold on for a second, just plugging everything in. And plug it in here. So it has started up. You can see the NXP logo. What does it say? And here the four penguins booting up. Hey, it actually worked. How about that? So it's booting up from the SD card. There's some sort of image on it. We are in VLAN. All right, so that means they have the GPU drivers included. Let me just plug in a mouse and a keyboard. While I don't know if you can you guys hear the thunderstorm?
I didn't realize I was muted. Yeah, I sure can.
Right. So for some reason my
You're gonna lose power.
oh I already am. I don't have power right now. I just have a beefy power supply.
Oh my goodness.
Like I am running off of a power supply right now.
You're on a you're on a generator on a battery.
It's a battery one, not a
Better fire up the diesel generator. Wow.
Hmm. So either it doesn't like my capture card or it's yeah it probably doesn't. The capture card doesn't always work. So I mean at least you guys saw it booting. That was fun, right? Let me see if I can reboot it and have it boot again. Um, and well, something isn't right probably with the capture card because at this point I should have seen the NXP logo. Yes, that is a beefy PSU of A13 Tech. It is like I almost sat down and was like, all right, time for open hours today, and it just started pouring. Ooh, that's a good one. Right. I'm just taking fun, just enjoying the thunderstorm while um, my capture card shows me its worse. Um, yeah, I don't know.
Electrostatic interference.
I'm pretty guessing if not probably not on the board side because like it's real industrial grade stuff. Um, if not ECC, they're at least protected by some other measures. But the capture card, it's a one hung low brand, and that could have not been good. Um, yeah, so the capture card is not working, but at least you got to see it booting once. Let's see if I remove the capture HDMI port, shut that down, plug it back again, and we have a blank screen, so that's good. Forward back. Hey, there's the NXP logo again. Well, there are actually cars whose alarm has gone off because of the storm. Hey, there we go. Right, so, um, oh, you know what the issue was? I forgot to turn on my keyboard. All right, so we have a Wayland terminal. Yeah, it's very dim on the capture card. I'm not sure why, but they usually have a graphics demo here with some of the NXP parts I've played with. Um, let's see if anything comes up. Um, no, I cannot see it. Not even GL Mark II. Oh, they have GL Mark II. Brilliant. Here we have a graphics demo running. Um, Yay. So you can see Vivante GC7000 Lite, that is the GPU. So this one has a reverse engineered driver. This image doesn't. So if anyone was to go ahead and enable this particular GPU in the mainline kernel and enable the HDMI port as well, they would get open source GPU drivers as well. So and Note 8. And here you can see the FPS, which is immensely impressive. My RK3399 Chromebook does half of that on average. On the open source GPU driver, granted, it's a very early work. Vivante stuff is much more mature, but yeah, it's a beefy GPU, and also has the hardware encoding and decoding stuff built in. So yeah,
That's really nice. That's impressive.
it is an impressive GPU. Yeah. Cool. So we still have 15 minutes. Let's see. Uh, yeah, A13 was saying if I can hook up a serial adapter, but HDMI worked again, so that's fine. Um, we have 15 minutes remaining. First of all, if anyone else has questions, do ask. Otherwise, A13, you can start asking your questions about your drone stuff that you wanted to ask, or if you just want a general update, then you can just type in the YouTube chat and I'll give you any updates you require. Right. Um, any questions so far? No? Okay. I'm just waiting for A13 to respond to anything if there's any specific questions you wanted to ask about the drone. Otherwise, I think it's a good time to call it off. I'll just wait maybe 5 more minutes for him to ask anything because YouTube has a fair bit of lag. All right, so A13 just wants a general update, which is cool. I can provide you with a general update. Let me just switch my camera here. Right, so what happened was somehow I managed to short out or just somehow overwhelm the tiny power supply that was a bad one.
You better take cover.
Yeah, that's like it probably grounded somewhere pretty bad. But yeah, so there's a power chip right there, which does the voltage regulation for the main sock. So there are two socks on this board. Um, so there's a little one which is the Nucleo sock, still an STM32, but which handles the flashing of the main sock and your embed bootloader ish kind of thing. So we just bypass this one. We are not concerned about this. But when you plug in your USB, this is the sock um, that your system actually sees, and it's pretty bad on there. And then it's responsible to flashing the main sock. And so I was able to see this sock, and then apart from that I was not able to interact with the board anyway. And if you touch somewhere around here, this place, all this general area was heated up. So I just took out the schematics, traced everything back, removed a bunch of capacitors, removed just stuff, and everything I removed was working. And at the end, what was blown out was the main sock. So I really couldn't fix it. So I had to order it and pay customs on it. At least it was refundable by Lenaro, so I'm very grateful for that. So that actually arrived. Here it is in the box. A new board, and yeah, so I'm working with this. So to solve the let's not overwhelm the onboard regulator. My current drone this update actually has onboard voltage regulators. So this one does, I think, 12 to 5 and then 5 to 3.3. These are all linear LDOs. So there's no weird frequency switching with the switching power supply and stuff like that. So I hope not to fry in the board. Else, I don't know. I'll have to see what actually is frying the board, which is not a happy thing to do. Yeah, so I guess that was the update about the drone project thus far. I'm actually going to either tonight or tomorrow morning going to push a few updates to Zephyr to enable a couple of SPI pins on the board itself and and a bunch of sensors that I want to use. So yeah, hopefully next open hours, if we don't get Savando, I can talk about that. Or if we do get Savando, then next to next week. we will talk about that. Um, yeah, it's all going to be open sourced. The only reason I haven't open sourced it yet is because there's no proper code that's been written. All the code that I've written is to test different sensors, to test all the motors, to test the relays, and just it's just a bunch of tests. It doesn't do anything apart from you boot it, and it enables a couple of things, and you can see them being enabled and working. And the drone design as whole, I have, I think, in my last blog, the blog I just linked on the YouTube chat as well. I have listed a bunch of basic things that I've used, but like the RB3 design, I will provide you with an entire bomb list so that you guys can just go and make it on your own. Yeah. So again, it's not. I don't want to call it like a drone project. This is not a done deal. This is something that I want to iterate upon every period, some fixed period of time. I want to make the base bigger, add more sensors to it. Again, most of it from the help and blessing of our partners. And I want to discuss with them what they want to see in the platform, how their how their base boards can be more um, like well displayed. So I have been thinking about MOSFETs. It's just kind of heat is yeah, relays are heavy and slow, but I'm not really concerned about the speed. I just want them switching once, and that's it. MOSFETs, I'm concerned about the heat because there are both things to consider. The amount of current that's going to pass through them will generate heat, and the times you switch it will generate heat. So I'm not switching at a high frequency. I'm just switching it on literally once. But the amount of current that flows is going to be massive because drone motors require massive current. That's why you have drone batteries and lipo packs that have like massive current throughput, like 50 amps. Now I'm not saying my drone uses 50 amps. I actually have to test how much my drone uses. So once I test that, and once I need to calculate then how much heat it's going to dissipate, once I have that numbers, I can plan on switching to a MOSFET. And yeah, they are heavy, but I don't think that they are that heavy. Um, and at the end, the next step, what I really want to do is create a custom ESC that will not require a relay. The only reason I'm using a relay is that the ESC itself doesn't have a way to feedback whether it's ready or not, apart from making weird sounds. Now, you cannot, the controller cannot, uh, you know, uh, infer if the AC is ready just by the sound, or it can do it if you add a mic and you add a bunch of ways of um, a way of getting the correct tones to it, recognize the tone pattern, and all of that crap from top to bottom. And then also, it's not as reliable because the environment can be noisy. So, relays or MOSFETs are sort of the way to go. Yeah, something else as a PWM. I'm not doing PWM on the relays. I don't think it's even possible. Um, Yeah, so the ESC, I'm only using the relays to switch on the ESC, and so that I know when it's ready. So, or if it's giving out an error. So what I do is, all right, start ESC1, like on my controller, I have start ESC1. ESC1 starts, makes a sound. I do the confirmation that ESC1 has started up successfully. Start ESC2. ESC2 initializes, takes a time, couple of seconds. I say, all right, ESC2 is fine. And then, so I have to do the confirmation stuff manually. I have to go around and tell the controller that the ESC is starting up successfully. If I design my own ESC, then I'll make it as such that the ESC and controller can just work it out. And the controller can then finally report to me if an ESC doesn't start, or give it the all okay if the ESC starts. Saves 10 seconds of startup time. I Yeah, there's some things about DIY drone equipment that I completely hate. But yeah, I'm looking to improve that, and hoping that I can create some DIY modules and open source designs that people can just take, mass manufacture, and we can just live in a better drone world as a whole. All right, 8:13 tech. I think we are top of the hour. I am going to close this call. We can go into after hours. You can join us over from YouTube onto a Zoom call for some after hours, and then we'll finally close it out in another 15-20 minutes. So thank you everyone on YouTube for watching. Hope to see you all in the next one, where we can discuss a few more things about hopefully AutoWare, if Savant decides to join, or just some drone stuff if I'm there. Um, yeah, thanks for watching, and I will see you all in the next one. Bye. And